Alright guys, what we just created were these two graphs, and the big one in this unit is called the absolute value function. Okay? The absolute value function looks like this. And basically we just had a couple of volunteers create this graph from a position that they were away from this wall. Okay? So we could say that they started at 8 feet away from the wall and they came back to 8 feet away from the wall. As they approached the wall, they reached 0 feet away from the wall. Okay? Now during this time, during this first interval, as they were approaching the wall, I'm telling you that there was a negative velocity. And the negative velocity means it was below the x-axis. Okay? So in respect to this wall, they had a negative velocity. As they moved away, it became a positive velocity. That's why it's above the x-axis. Okay, so if I were to tell you that this is the origin, and then I were to ask you, what kind of slope does this line right here look like it has? What would you say? Just y equals x. Okay? So this right here, it looks like y is equal to x. And what do you think this looks like? Y equals negative x. You with me? So y is equal to negative x would look like this. Now this is all referencing our y equals mx plus b. Okay? Real quick, what you're about to see and recognize is the importance of the number that's in front of the x. What number, what slope is this one? 1. And what slope is this? Negative 1. You with me? So slope is big in this respect. As I'm approaching the wall, I have a negative 1 slope. I have a negative velocity. It's like something falling down, something moving to the left, or if you're driving in your car, it's like moving backwards. Now I know the way they were doing this, they were moving forward, but it had a negative velocity. But I want you to imagine the only way that that would work is if this was facing the wall. So they couldn't do it this way because it would be totally different. It would register across that wall. Actually, it'd probably register across some of you. Okay? All right. But nonetheless, thank you. And then go ahead, grab the calculator on my desk, please. As the students were approaching the wall, they had a negative velocity. But what did they have the entire time that was positive? Think about that. That's the big part of today's stuff. What was positive the entire time? The distance. The distance from the wall was positive until no one hit it, but if they had, it would have been what? 0, and then it was back to positive distance. You with me? So a huge idea of absolute value is that it's an absolute value distance. In other words, it's never a negative distance. Can you cut for me 5 feet of rope? Yeah. Could you cut for me 10 feet of rope? Yes. But can you cut for me negative 3 feet of rope? No. So absolute value is measuring all positive values because it's an absolute value distance. Okay? The best way that I can tell you is this. It's the distance from 0. Okay? Here we go. Let's say here's 0, and I picked a number 5. You with me? This value, the absolute value, is the jump away from 0. So if I go from 0 to 5, how far is it? 5. 5 feet of rope. You with me? What if I went to a negative 5? How far is this distance? It's still 5. You with me? I still get the same positive 5 feet of rope. So fundamentally, when I'm talking about position, I can take the absolute value of 5 and I will get 5. I can also take the absolute value of a negative 5 and what do I get? 5. So a good rule is that it will make anything positive. You with me? But that's not how I want you to remember it. I want you to remember that it represents the distance from 0. So when we start getting to more complex transformations and stuff, you're understanding what's going on. Okay? The other part was velocity. Okay? And from negative infinity all the way to 0, the slope was negative 1 on this parent function. And from 0 all the way to infinity, the slope was a positive 1. You with me? What was the slope at 0? There's no slope. You with me? So if I have a negative x, negative 1, and I have a positive x, positive 1, right here we call these things cusps, basically a corner. You can't see what the slope is because it's neither 1 or negative 1. So we just say it's undefined. It's not a slope. Okay? Yeah?
So with the interval notation, will still be a parentheses or will it be a bracket because like it touches on the 0?
So it's going to be a parentheses because at 0 it's not 1. Because that's a really good question. Do you hear what he's saying? Does there belong a bracket at 0 on any one of these? No, because you can't fail the vertical line test per se with slope. If I told you at 0, what's the slope? Some of you might say 1. Some of you might say negative 1. But you're both not correct because it's neither 1. You with me? Okay. And that's like calculus stuff. If you can kind of start getting into that and understanding what that's talking about, that's all calculus interpretation. Any questions so far? Okay, so distance-wise, the absolute value will always be what? Positive. And it's always representing the distance away from what number?
0.
0. Okay? Alright. So let's go ahead and go to our notes. Alright, so let's go ahead and begin. The absolute value parent function, the way it begins is f of x is equal to the absolute value of x. Okay? So again, the big thing, these are representing the absolute value representation, but also saying that that's the distance away from 0. Okay? Alright, we'll get to that here in just a bit. Alright, so if I'm looking at these values, and let's say I plugged in negative 3 right here for x, what would I get as an answer? 3. Okay? So I'm going to get a positive 3. That means f of x is equal to what? 3. Therefore, my point is at negative 3, 3. So left 3, up 3. There's where I would put a point. Okay? Plugging now this 2 up here where x goes. What do I get, guys? 2. The f of x answer would equal 2. And therefore, my point is what? Negative 2 and 2. We're going to go ahead and start graphing these. So negative 2 and 2. So let's jump to 0. Let's plug 0 in. What would I get? 0. Is 0 positive or 0 negative? Neither. Okay, so 0 will always be 0. But nonetheless, the absolute value is always going to spit out a what value? A positive. A positive. So, but don't interpret 0 as positive. Okay? 0, 0. So yes, f of x would equal 0. Otherwise, 0, 0. Guys, just a reminder, all we're doing is an XY chart. So these are x's, and these are y values, and we're just going to put them as a point of where they're located. Okay? Alright, so negative 1, let's go, Brianna. What would negative 1 become? 1. And f of x is? 1. And my point is what? Perfect. Tyson, what would positive 1 give me? 1 all the way, right? And then what's my point? 1 comma 1. positive 2? 2, and it's just 2. So this is fairly easy, right? And then you just go and you put all the numbers, right? And then I'd get 3, 3, and the point would be 3, 3. So we go negative 1, 1. Then we'll go 0, 0. We'll go 1, 1, 2, 2, and 3, 3. Because we were graphing these points right here on the graph. And then from there, we're just going to piece them all together and see what kind of graph we see. And you see something that looks like that. Okay, so the absolute value graph, again, will look like this. Cool? Now, this slope from 0 to infinity, what did we say it was? 1. And then this slope was what? Negative 1. And this is from negative infinity all the way to 0. And just for extra practice, guys, how do we write these intervals in algebraic notation?
X is the element of all real numbers, and X is greater than 0.
So X is greater, so that's set notation. The more basic form is just the inequalities, okay? So this would be X is what? Greater than 0. Right? So please don't do this. I didn't take off, but I will take off this unit if you're still doing that. Don't write it like this, okay? Just write the X is greater than 0 piece, or if you want to put 0 is less than X, that's fine. I didn't take off this test, but I will going forward if you are still writing this stuff, that less than infinity stuff, okay? So make sure to refine that for next test for sure. Okay, what would this one be over here? X is less than 0. Perfect. And then one more last thing. What did we say the slope is at X equals 0? There is no slope, right? It does not exist. So we'll say just, it's not really undefined. Because an undefined slope looks like a vertical line. You with me? This is more like it just does not exist. Okay? So we'll just put D and E for now. Are we good? Okay. So let's keep going. And we kind of already showed the domain. So my graph, I'm going to just do a quick sketch here. Look like this. And let's go with, to review, what's the domain of what you see right there? To what? To infinity. You could put negative infinity to infinity. This is interval notation. Riley, what else could you put? All real numbers. So you could say all real numbers like this. And if you went beast mode and went all the way to set notation, Thomas, what would that be?
Not so much the second two, but doesn't it imply that you're also passing on 0 even though you told us the parentheses around 0?
So no, this is including 0.
Oh, okay.
So listen, this is a good question. The parentheses for 0 was not for the domain. That's not what we were talking about. We were talking about the slope. What was the slope? Now we're saying, where does it exist? Where does the graph exist? And it exists everywhere, including 0. You with me? So we will put X such that X is an element of all the real numbers. Questions? Please ask me if you have. Okay, here we go. Corbin, what's the range of this graph?
0 to
Perfect. 0 to infinity. We know this is parentheses. Corbin, what's the, is it bracket or parentheses at 0?
That's a bracket.
It's a bracket. These are important, guys. Parentheses and brackets are huge right now because you're learning parent functions. Okay? What's another way that we could have written this? Because right now we did it in interval notation. What's another way we could have, Skylar, what's another way we could have written the range?
Like 0 or like y is
Mm-hmm.
greater than 0.
Close. Y is greater than or equal to 0. because I am touching the x-axis. I exist at the x-axis. It's not like I have a hole in the graph there. No, it's not a hole. It actually comes to a point that is filled in. Okay, so up here that would be equivalent to like negative infinity less than x less than infinity, stuff like that. Okay, but again, this is the interval notation, more preferred, and you could also just do all real numbers. So the interval notation with algebraic, that's pretty much it. There's no other way that we could really write this out unless it's set notation. And that would be the set of all y such that y is greater than or equal to 0. Easy? Okay. X-intercepts. Michael, what do you think whenever you see x-intercepts, what do you think I hope you immediately think about? Yeah. Let me help you out. Something equals 0. Not 0 equals 0. When y equals 0. Okay? So y is equal to 0. Like a point, it would look like that. And the x-intercepts that you're about to list are those. Vice versa, Sarah, what do you think I want you thinking immediately when you see y-intercepts? X equals 0. So guys, quiz, test, CFA doesn't matter. When you see x-intercepts, immediately think y equals 0. When you see y-intercepts, immediately think x is equal to 0. And the y-intercepts, whoops, are those values right there. Okay? Santiago, what is the x-intercept that you see in this parent function?
0.
0. So you'll say x equals 0. That's the answer. Okay? If you put this point right here as 0, 0, is this whole thing my answer? Is that my x-intercept, the whole thing? No, it's not. My x-intercept is just that piece right there. Because the x-intercept happens when y is equal to 0. Do you see how I'm highlighting them though? Okay. So, Nate, let's go to the y-intercepts. What y-intercepts do you see? 0. But we're not just going to put 0. We have to specifically write y equals 0. Okay? Because we're talking about, okay, let me highlight it. We either write it like this, or we can write it like that, showing that this is the y-intercept. Or, sorry, that's the y-intercept. When x is 0, it will show you what y's value is. Okay? Axis of symmetry. Okay, so let's go with symmetry. Anna, what is axis of symmetry? What do you think it means? Yeah, it's a straight line. She's actually absolutely right. It is a straight line. And symmetry has some kind of symmetric feel to it. In other words, balanced equalness to it. So what would you say?
Is it like the straight line that can cut it?
Yeah, perfect. That's the axis of symmetry. So the axis of symmetry is going to cut this line perfectly in half, and it's going to do it in a vertical way, where it looks like that right there. There's your axis of symmetry. Okay? Owen, what's the equation of that dotted line that I just drew? Perfect. X is equal to 0. Notice it doesn't say y equals mx plus b. It doesn't have a y. Because if it did, it would be diagonal of some sort. You with me? Remember, if it has x and y, then it's going to be diagonal. If it only has y, what is it going to be? Horizontal, yeah. This is horizontal, where it looks like this. And if it only has x, what would it be? Vertical. in this case, we see it's x equals 0. And if it has both, what would it be? Diagonal. It could either have a positive slope or it could have a negative slope. Just a little review-ish with that kind of stuff. Okay, the vertex. The vertex is the point at which this absolute value has no slope and will change directions. You with me? All right. This one we actually give full as x and y. So Brittany, what would that be? It's okay. Try it.
I'm really blanked right now.
Oh, it's okay. 0, 0. Yeah, so this is going to be 0, 0. It's the location on the graph where the corner, you can write the tip or corner of the graph. Okay? That's what the vertex means. Okay? Real quick, let's go back to geometry just for a little bit. What shape is that I just drew? A pentagon. N is 5. And if I asked you, how many vertices does this have, what would you say? 5. What does vertices mean? The tips, the corners, the angles. Okay? So a vertex is a singular form of vertices. You with me? Like radius is 1, radii or radiuses, whatever. I'm just making that up. So vertices is plural form for a singular vertex. Okay? So that's what that 0, 0 comes from. All right. Do I have a max or min? Will I have one or the other, or could I have sometimes with this graph, could I have both? What do y'all think? I could have both, but it won't be at the same time. It'll either be a maximum or it'll be a minimum. You with me? So let's think about this. Let's say that this was your bank account, okay? And it was just going down and going down and going down because you're spending like crazy, especially because the holidays are right around the corner. But then you stop spending so much and you start saving again. You with me? Did you just experience a max or a min? A min. Now this is very important what I'm about to say. What's the min? 0. Which of those values is the min? There's only one of them that will represent the min. The y value. That's so subtle but very important, okay? So this will tell you what the minimum value is, and this will tell you what? Not the max. It'll tell you when or where the minimum value occurred. Think of it like time. Sometimes this will say like 5, 0. So it could be a graph that looks like this. At 5 seconds, I experienced the minimum velocity or position of 0. You see what I'm saying, guys? So it's very important that you know this is basically when or where the location is. And this is telling you what is that value. Okay? And in this case, it's going to be a minimum. What kind of graph would I have if I'm experiencing a maximum? You see what I'm saying? What would you do to this graph to make it look like a maximum? You reflect it. Yeah, reflect it across the x-axis, and it would look something like this. And basically you have the top of a mountain. You have a peak. You have a maximum value that just occurred. You with me? And just to see what you think right now, what would be the equation of that? If the original blue one was this, and I'll tell you right now, this red one that I made up, it's actually this. X minus 5. Even shifted it to the right. I know, we'll learn about that starting tomorrow. What do you think the equation to this one is? Negative absolute value of x. Perfect. Cool? Alright, last but not least, the slope of the sides. That's really the last thing we should learn, but that was the very first thing that I introduced to you, because it's very important. What's the slope of the left side? Negative 1. So we're going to say m is negative 1 on negative infinity all the way to 0. Remember, like we were talking with Thomas, it's not bracket, because the slope at 0 is not negative 1. We good? Alright. Grant, what is the slope to the right? What would you say?
Equals 1 on 0 to infinity.
Perfect. So from 0 to infinity, parentheses on both, like Grant said, the slope would be 1. And last but not least, just so that we know, what's m at? So these are on. On means like intervals. At means at one point. So at x is equal to 0, anyone, what did we say the slope was? Does not exist, right? You could do undefined as well, but we're going to put it does not exist. Because I strictly try to reserve undefined more so for when I'm dividing by 0. Okay? And I'm not dividing by 0 here. It's just, it's a cusp. It's called a cusp, the corner. We'll put that right there. That's already calculus stuff. We good? Alright. So, that's the first one. The notes that you guys grabbed on your way in, they will be due for homework next time. So there's a lot of stuff that we're going to be working on with these graphs, but I want to do a couple of more example problems with you so that you have a solid understanding of what's going on. Okay? So let's go over to, let's go to number 2. And then we'll jump around. Hopefully we can do like one, at least one, maybe 2 to help you guys out with some homework, okay? Alright, so number 2. My function is now changed. Okay? F of x, let's highlight this together. F of x is that. Do you see how it labeled it? F of x is equal to the absolute value of x. So another way that I could write g of x is basically my original, then minus 3. Okay? Here we go. The domain. First of all, let's graph some points first. Okay? Let's graph negative 3, negative 2, negative 1, 0, 1, 2, and 3. Those are always good points to start. And sometimes, like I'm a little lazy, I might not go to negative 3, but I at least do negative 2, negative 1, 0, 1, and 2. Negative 2, negative 1, 0, 1, and 2. Negative over and over on all these that we're about to look at. Okay, not just today, but in the next several units. Alright. So if I put in a negative 3 into my g of x function, everywhere where x is located, what I'm really doing when I plug in negative 3 is it looks like this. Let me build the function. Remember when we did function notation and compositions? We're inputting an x value that is negative 3. Okay, here we go. Aaron, what would I get just from this piece? 3. Now I still have to do this leftover part. And anyone, what would my answer be? 0. Okay, and now go ahead and plot it. Negative 3, 0. Alexia, what if I put negative 2 in? Alexia, what would I get? If I put negative 2 into the equation, what would I get as a final answer? Let's put it first. Let's write it out, okay? So I'm building this like this. And what I'm going to plug in, Alexia, is a -2. Where x goes. Okay? Alexia, what do I get for that piece right there? What would I get, Joel? 1. Okay, for a total answer, I would get... I'm just talking about just this piece right here. We have to absolute value -2 first. So anyone say it out loud?
2.
I would get 2. Because absolute value makes everything what? Positive. Everything on the inside, it will come out as a positive. You with me? Okay. So if I write down +2, and I still have to subtract 3 from my answer. It's like a 2-step process. Now, anyone, what would I get as a final answer? -1. Okay? Alright, so I want this in 2 steps. Let's first put the -1 in the absolute value, tell me what you get, and then subtract 3, and then tell me what the final answer is. Okay? So Sarah, let's plug in -1 in where x is located. What would I get? I would get a +1. And then when I subtract this negative, or when I subtract that 3, what would I get? -2. Okay? Nice. Nate, let's plug in 0. What do I get? -3 as a final answer though, right? But let's do it in 2 steps, just for instructional purposes. What's the absolute value of 0? 0. And then subtracting 3, you're absolutely right. Madeline, we're going to plug in this +1 now into the absolute value. Just for the absolute value piece, Madeline, what do I get? 1. Now subtract the 3, whoops, and what would you end up with? -2. And everyone, what are these last 2 numbers going to be? -1 and 0. So let's graph these. -3, 0, -2, -1, 1, -2, 0, -3, 1, -2, 2, -1, and 3, 0. So my graph looks something like this. Okay, here we go. Anyone can say it out loud. Don't worry about raising your hand. What's the domain? -infinity to infinity. And someone else said all real numbers. Okay. What's, yes? Oh, I just want you to put both just for the practice. So the ones that I'm really looking for are interval and inequality. Whoops. Okay. The set notation, remember it, but not for right now. I'm not really concentrating on that. Okay. All right, here we go. The range. Anyone, what's the range in interval notation? 0 to infinity. Parentheses or brackets? What goes on 0? Parentheses or bracket? Bracket, because I'm touching 0. Oh, it's not 0 to infinity, is it? There we go. It's -3. Nice catch. It's -3 to infinity, because the lowest that it will go is y equals -3. That's the lowest that it went, and it touched. And because it touched, we close it up. Okay? All right. Let's write that in inequality notation. How would I write that? Y is greater than or equal to -3. Remember, don't put that infinity stuff with those inequalities anymore. Okay, I will deduct points going forward. All right. X-intercepts. Immediately, you should be thinking what? Y equals 0. Guys, when does y equal 0? At -3 and +3. So look, you can do it like this. -3 and +3. Or you could do it like this. ±3. You see what I'm doing? And the last thing that you could do it if you wanted to, you could list out the points. You could say 3, 0 and -3, 0. Good? Know them all, okay? All right. Y-intercepts. Immediately, x equals 0. What's my y value when x equals 0? -3. But I need to write it as what? Y equals -3. Guys, if you just put -3 on the quiz, I will deduct points. Because I don't know if you're talking about an x or a y. Okay? So please make sure you're very descriptive of exactly what you're saying. How about if I did that as a point? What would that look like? 0, -3. Okay. On a, where's our axis of symmetry? X equals 0. It is still right in the middle, and it did not shift left or to the right. Are we good? Brittany, what's our vertex now? 0, -3. Catherine, did we just experience a max or a min? A minimum. And watch, I'm going to put the minimum is y equals what, Catherine? -3. This is the minimum. You with me? If I put it like this, if I put it like the point, you could do this and get full credit, but I'm afraid that you're not going to understand that it's the y value if you put the point. I'm afraid that you're going to think it's a point, and it's not. It's not the point. It's the y value at that point. Okay? It'll make calculus a lot easier in 2 years. Yeah, so let's circle min. And the slopes. Are the slopes still the same, -1 and 1? Yes. So we're going to put m equals -1 on -infinity to 0. M equals 1 on 0 to infinity. And again, that does not exist. That's just an extra extension. You don't necessarily have to list it out. I'm more so concerned with the positive and the -1. But you guys are killing it, so I'm going to put does not exist at x is equal to 0. All right, transformations. Transformations is basically, to me, I just imagine like I'm playing with clay or Play-Doh. Back in kindergarten or whatever, when you're playing with Play-Doh, you're just transforming things into different shapes. Okay? The original piece right here came from the original function. And to me, what I imagine, this original is like the original piece of clay that you got when you pulled it out of its container. If you can remember, this shape, this cylindrical shape, is the original one that I imagine. And when I pull it out of its container and I mess with it, and I make like, I don't know, a bird, I just transformed it. You with me? So this bird is this graph here. And you tell me, how did this transform from the original? What happened? It shifted, or it moved. The word that I'm looking for is shifted 3 units down. So shifted 3 units down. And you could put like a down arrow if you want. Okay? The word that we're ultimately going to use starting tomorrow instead of shift Yep, it translates. And not translates like English to Spanish or German or whatever. This translates means it just shifted. Slide to the left, slide to the right, whatever. Okay? From all your homework problems that you now have in front of you, look at them for a little bit, and you tell me which one do you want to do with me right now? Which one do you feel would be difficult? Yes, Brianna. Number 8. Let's go to number 8, guys. Alright. G of x is going to multiply my input x value. This is a good choice too. My input x value by 1/2. So I have two choices. It'll either look like this. You with me? Or it would look like that. Thank you. Which one do y'all think it is? The first or the second one that I wrote down? It's the first one. This is huge as far as what changed. You with me? What changed is what it's all about. You will either change, guys, this is a huge unit talking about transformations. It's talking, you did this in geometry, like translations, dilations, reflections, and all kinds of stuff. And you had like a triangle ABC with its transformation of A prime, B prime, C prime. Okay, but now you're going to do it to these points. Oh, you could just leave that out for now. Okay, yeah, just come on in. All right, here we go. So let's check some points. I'm going to jump around just a little bit. And I'm going to pick numbers that I can multiply by 1/2. You with me? Here we go. I'm going to pick -2, -4, and -6. I'm going to pick 2, 4, and 6. You see where I'm going with this? Yeah.
So when you're doing these graphs, you don't have to stick to the negative.
Yeah, you don't have to stick to -2, -1, 0, -1, 0, 1, and 2. I think you need to look at what you're doing and start thinking about it in your head. What numbers should I be picking? Now here's the thing. Can you always pick -2, -1, 0, 1, and 2? Yes. But it won't be as easy to see what the graph is doing because you have a lot of fractions and decimals and stuff like that. You want clean whole integers. Okay? So anyone, when I plug this number in, what's first going to happen to this -6? It will multiply by 1/2, right? What do I get? -3. The second step that happens, is going to be this step right here. So I have a -3 right now, but after the absolute value is applied, what would I have? A +3, right? So it'll be a +3. There we go. -4 times 1/2 is a -2. I absolute value that, and I get a +2. You with me? Michael, do the next one. -1. Perfect. Just like that. Joel, do the next one. It would be 0, but do the steps real quick. Perfect. That's exactly how I want you thinking about it, okay? As you go through it. Toribio, let's do 2, a +2.
So you do 2 divided by 1/2, which is 1, and then absolute value is 2.
Okay, so he got the right answer, but there was one thing that he said that was actually incorrect. He said divided by 1/2. That is a common mistake. He's not alone. A lot of people say that same thing. If you divide it by 1/2, it's the same as multiplying by the reciprocal. So be careful of how you say it, because he could have said one of two things: multiply by 1/2 or multiply by 1/2 or divided by what? 2. Okay? So this right here is dividing by 2. Cool? Alright. So yes, he was right. You do get a 1 at the end. What would I get after 4? 2. What would I get after 6? 3. Go with me? So let's plot them. Negative 6, positive 3. Then negative 4, 2. Negative 2, 1. 0, 0. 2, 1. 4, 2. And 6, 3. All right, this is definitely different than what the easy shift that we did before was, right? Here we go. Anyone, what's the domain? All real numbers. And you could put interval notation if you want. Okay? What's the range? Y is greater than 0 or equal to, right? Or interval notation? 0 to infinity. Infinity is always parentheses, but you tell me, bracket or parentheses at 0? Bracket, because why? It touches 0. Y equals 0. Okay? X-intercepts. Immediately, y equals 0. Where does that occur? At x equals 0. Now we're getting it. Now we're getting it. Y-intercepts. Immediately, x equals 0. And where is that happening? At y is equal to 0. Don't let that confuse you. That's why I'm trying to go with this immediately thing. Anna, what's the axis of symmetry? X equals 0. It did not change. It didn't shift left or right. Like it could have been a graph that was way down here. And we're going to see all kinds of different graphs and stuff. Vertex. Brittany, what's the vertex? 0, 0. Catherine, max or min? Minimum. And it occurred at what? What would you write on the quiz? Y is equal to 0. Perfect. Okay. Tyson, what are the slopes? This is when it's different. This is why I'm glad Brianna chose this, because this is different. So let's say on negative infinity all the way to 0, which is right here, on that interval, Tyson, what is the slope of this line? Up and out, Sima.
Oh, just the gray line?
Close. Just the blue line that I graphed right here. What's the slope of that? Negative 1/2. Down 1 over 2. Down 1 over 2. Y'all with me? So it's going to be m equals negative 1/2 on negative infinity to 0. Daxon, what's the slope after that? Well, this one is, yeah, this one is. But I'm saying, like, now go to 0 to infinity. Positive 1 over 2. Yep. M is equal to positive 1 over 2 on 0 to infinity. And everyone, at 0, what's the slope? Does not exist. At x is equal to 0. All right. This transformation is a little bit different. How did this graph change? It opened up, the slope changed. Now I will give you a choice and you pick. Did it change? Did it change horizontally or did it change vertically? You could say both. You could actually say both. It looked like a vertical compression, a vertical squish, because it made the graph do this, because there's a lot of weight on it vertically. But also some of you could say it was a horizontal stretch that made it do that. You with me? Because it was with the x, it's going to be horizontal. You're going to learn this a lot next class for sure. If it's y, then it's vertical. So here's my question to you. The biggest question so far right now is, how do you know if it's with x? And how do you know if it's with y?
It's inside. Separation.
If it's inside the parentheses where x is located, it's going to be x. If it's outside of that parentheses, it's going to be y. So our original equation today, guys, was this. This is huge. Anything inside with x will be all in here. Okay? And everything on the outside would be in front or out here. That's how you know if it's horizontal or vertical. So I'm giving you a little prelude into next class, transformations. Go with me? Now here's the best thing that I can say for you to remember and learn it fast. If it's with the x, I'm going to put like x, like your x. It's the opposite of what you think. If it's y, you follow the rule. Okay? So if it's the x, it kind of makes sense. Your x is your x because you were doing the opposite. Okay? But if it's not with the x, you follow the rule of what it looks like. You with me? So here's what I'm going to say. This 1/2, you're going to learn next class, it's not a horizontal compression by 1/2. It's actually a horizontal stretch by 2. And you'll learn this next class. Okay, so let's go ahead and put that. Horizontal stretch by the reciprocal of 1/2, which is by a factor of 2. Any questions before I stop the video? Awesome job, guys. There's a lot that you're going to learn this unit for sure. A lot of important stuff this unit. A lot. And I think it's still even easier than last unit, okay? So make sure you do your homework. Please have it ready for next class.